Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about what is mean by insertion sort. Okay, so what is mean sorting? As I told earlier, sorting means arranging the elements in either increasing order or in a decreasing order. So the technique to arrange an array in this way is called sorting, right? So what is mean by insertion sort? What is mean by insertion sort? See here, from this name, there is what insertion. What is my insertion? Just insert between two intervals or two values. Okay, there's some value here and value here, just insert here. So this is the meaning of insert, right? So so this algorithm uses the insertion method. Okay, so let us see what is mean by insertion method. Let's see. First of all, we want to iterate from one index. Okay, we will partition this array into two parts. That means in first iteration we will take this as my sorted array and the remaining as my what unsorted. This I consider like this. Okay, this I consider. Now I am taking this 10 and checking whether 10 is less than 11. Yes, it is less than 11. So can you swap it? Yes, swap it. That's all. We don't have any elements to the left of the 10, right? So just keep it here. Let me write it. Yes. Now, 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 just observe carefully. Here 10. Sorry, here 11. Yes. Now, observe carefully. I can say these all is sorted now. I can consider like that, right? And these all are unsorted. Okay. Now again, now the same process is repeated. Now check whether 5 and 11 is less than 5. No. Just swap it. Here comes 5 and here comes 11. Whether 5 is greater than 10? No. Just swap it. So what is my array now? 5, 10, 11, 2, 3, 4. Yes. So now these all are in sorted and remaining are unsorted. Okay. Now I'm taking this 2. Whether this 2 is less than 11. Yes, it is less than 11. Just swap it. Whether this 2 is less than 10. Yes, it is less than 10. Just swap it. 2 comes here, 10 comes here. Whether this 2 is less than 5. Yes, just swap it. Right. Now, what is my elements? It is 2, 5, 10, 11, 3, 4. Yes. Now, if you observe carefully, I can say these all elements are sorted, are part of my sorted, right? Because I am just inserted and this is my unsorted. Now take this 3 and check with 11. It is less than, yes. Swap it. Now check with 10. Yes. Now check with 5. Yes. Now check with 2. No. So stop there. Don't go. Okay. Now what is my array? 2, 5, 10, 11. Sorry. 5, 10, 11, 4. Okay. This is my array. Now again take this whole as my sorted. It's all sorted, right? It's all sorted. Only this is my unsorted, right? Now take this 4 and then check with 11. Whether 4 is less than 11. Yes. Swap it. Whether 4 is less than 10. Yes. Swap it. Whether 4 is less than 5. Yes. Just swap it. Whether 4 is less than 3. No. Stop. So this is my final output. What? 2, 3, 4, 5, 10, 11. My array is sorted. Yes. So this is what insertion sort. We are just finding the insertion position in the sorted list. Okay, and then we just go and put there. That's all about this insertion sort. So what is the time complexity here? What is the time complexity? I'm just taking an element, then checking with the remaining elements in the left. So I can say I'm taking one element and checking with the overall the array elements. So I can say what is time comes t? It is n square. And what is space comes t? I haven't used any space. So it is O of 1, which is constant, right? So this is what the approach and time complexity of this insertion sort. Now let us see the code. See here, I gave an array. Then for I in range of 1, len of arr, key is equal to arr of I. Yes, I store the arr of I in a key. Then j is equal to I minus 1. I told you, right? I want to check in the left side if there exists any less than value. Okay, sorry, greater than value. While j is greater than 0 and key is less than arr of j, which means if the key, that is the current I value element, is less than the any value in the left, then I want to what? Move, right? Move. That's why I'm doing what? Just assigning. just assigning. Instead of swapping, we can also assign. Okay, I can do swapping. Just wait. It will be more clear when I do swapping, right? You can also do the assignment. I say you y, but I just swapped, okay? Then j minus 1 because we have swapped. Next we are swapping, so j minus 1. Now ARR of j. So while swapping, we don't want it. Okay, I will comment it rather. We don't want it. So this is my code. Let me submit it. Okay, it is sorted. So this is what I have told you. But still, you can also do it in another way. Like you can assign the values. Like see here j plus 1 is equal to AR of j. Why? Because just I write a code snippet. Just observe carefully. Just assume 2, 3, 5, 4, 10, 11. Let us take. These all are in sorted order. Okay. Now I am currently with the 5. Whether 5, these are in sorted order. Let us take. Now I am currently with the 4. Okay. Whether 4 is less than 5. Yes. I just don't want to swap it. I just make this 4 to store in a some variable, some temporary variable. Temp is what? 4. And then I will take this 5. Okay. Take this 5 and update here. 5 is here. 5 is on there. But I will take this value and assign here. Understand? And I will check whether this 4 is less than 3. No, no. Then I want to do what? I want here is my pointer. Now I want to make j plus 1 and I want to update this 5 as what? 4. So my array will be what? 2, 3, 4, 5, 10, 11. Right? So this is the step we are doing in the current code in this code. Okay, we can also do the swap method. We can also do this. Whichever you like, you can do. But output should be correct. Okay. I have told you right. J plus 1 should be what? Let us see. Okay. So two ways is same. Whichever is easy for you, just do it. Okay. Thank you.